Okay, this is 3.6 Rational Functions, Day 2. And we're just going to get into a little bit more graphing, a little bit more in depth. It says for numbers 1 through 3, describe the end behavior modeling using one of the following. Okay, so some end behavior that we have talked about is A says y equals 0. Remember that is bottom heavy as I have described it. Okay, on y equals k, this means you have both the top and the bottom exponents are exactly the same, so you have a ratio of the leading coefficients. On C and D, this is when you are top heavy. You're going to have a slant asymptote. And on C, you have a linear function, so when you do your division, you end up with a linear function. So it could be y equals x or y equals x plus 3 or something to that factor. And then on D, you have a polynomial function. So your degree is greater than 2. And we did graph one where you had a parabola. Okay, so all of these talk about your end behavior. So what I'm looking at is your exponents. And of course you have a top heavy here. So you're going to have a slant asymptote. Okay, so that narrows it down to either C or D. And I don't want you to get too much in depth in this, but I want you to figure out, you know it's between C or D, and if you have to divide this, go ahead and divide this. But looking into this, I know if I divide this, it's not going to be any more than a linear function. So this is just going to be C. And I don't care if you go into more than just knowing that it's going to be a linear function y equals x. Okay, looking at these, this one right here, number 2, my exponents are exactly the same. So this is going to be like B, my ratios are the same, so this is going to be B, y equals 3/7. On this one is already factored. They've written it, looks like they've already divided. They've written it as your divisor and then x plus 3 over x squared plus 4. So it looks like it's going to be a C or D. But if I were to go ahead and rewrite this, meaning go ahead and find a common denominator, just to kind of show you what happens, this would be an x squared plus 4. And put that over x squared plus 4, then it looks like my top is going to end up to be greater than the x squared. So I'm thinking this is going to be fall in the D range, which is going to be a polynomial, a parabola maybe. It's going to be greater than that x squared. Okay, now let's do some graphing. It says sketch a rough graph. You've been doing rough graphs already, so I'm just going to continue to do the same thing. Now I'm following Frady, and that's what I want you to continue doing the factoring and so forth like that. Okay? And see if there's any holes, and it doesn't look like there is, so let's go ahead and find our roots. So that's your x-intercepts. And I do want you to make sure that you're labeling everything here. So the x-intercepts are going to be negative 3, 0, and 3, 0. And you realize that this one is a square, so that's going to be make a big difference. Okay, your asymptotes. Going to label some stuff to leave some blanks. So my vertical asymptote is going to be x equals 5 and x equals negative 4. And neither one of those are a square, so that's great. Your horizontal asymptote, I know this is not multiplied out, and I don't have to worry about it multiplied out. I have an x to the first and x to the squared, so that is going to be x cubed over x and x, so that's x squared. So this is top heavy, so you're going to have a slant asymptote. Okay. Now we are going to have to go ahead and multiply this out, unfortunately, to see what's going to happen. So this one right here is x squared minus 6x plus 9. And then if I multiply it times that, it looks like I can't do synthetic, so I'm going to write it out here. So the inside is going to be x cubed minus 3x squared minus 9x plus 27. Whoops, made that a little check mark. And then the outside is going to be the bottom, so that's x squared minus x minus 20. Now remember, and I'm going to stop because this is going to give me my slant right here. So y equals x minus 2. That's all I worry about. Okay, y-intercept is going to be 0 and a huge number. How about negative 27 over 20, since I already had that multiplied out? Okay, now let's start doing a sketch here. My x and y axis, that would make more sense. My vertical asymptote at negative 4 and 5. A slant at x minus 2. Negative 3, 0, 3, 0. And I have no holes. And then this number right here, negative 27 over 20, is going to be about right here. Okay, let's change colors here. All right, so I know I'm going to go through these points, but I really have no idea where anything else is going. How about I connect? I'm not sure. Remember, you can go through slant or horizontal asymptotes, so I would say for sure that I'm going to do this. Okay, let's see what we're going to double on. X minus 3, we're going to bounce back. So at 3, we're going to bounce back. So how about we go here and bounce back? So how about we go down? And it looks like this one is leading up. And we have no other squares. So if that's down there, this is going to go up. If this one's up here, this one's going to go down. Okay, let's try another one with all our information. Already factored and no holes, but we do have some squares here. So x-intercept gives you 5, 0 and negative 2, 0. Vertical asymptote is going to give you x equals 0. I'm going to have one at x equals negative 3. And I'm going to have one at x equals 4. And I do have a square at 4. Horizontal asymptote, I have 1, 2, 3, so I have an x cubed on top. And I have 1, 2, I have a 4 on bottom. So I have y equals 0. That's a bottom heavy. Okay, y-intercept. If I plug in a 0, it looks like I have none. So it's not crossing the y-axis at all. 0. Negative 3. And then I have one at 0 as well. And then I have a 5, 0, so 1, 2, 3, 4, 5, and then negative 2. Okay, so this 2 is going to be a bounce back, and then this 4 is also going to have arrows that bounce back at that as well. So that's going to be a double. Okay, right now I really have no idea what's going on with anything. I know I'm going to have a graph in here, but I don't have any points, so I think that's kind of crazy. Here, I'm going to have a bounce back, and I don't know anything that's going on here. So how about we start? I'm going to pick a point over here. So this is 1, 2, 3, negative 4. I'm going to try a negative 4 and plug in a point. So if you plug in, if I just had a t-chart and I plugged in a negative 4 up here, of a negative, I'm going to come over here. This negative times negative, that's positive. So a negative by that, I don't even care what my number is, but a negative 4, my y value is going to be negative. So at negative 4, I'm going to have a negative point down here. So I'm going to draw this figure down here. So that gets me started. Now, in this section right here, I'm going to have, since -3, my vertical asymptote was not a double, that means that it's going to be up here. Okay? This point, it's going towards this point. Let's see if that was a double. It was, so that means it's going to bounce back. That tells me that section. Okay, in this section right here, 0 was not a double, so that means I'm going to come down here and draw. I cannot cut through my x-axis because it did not have a point, so that means I'm going to come up and come back down because I did not have any point at all. I cannot cut through that again. Okay, 4 was a double. That means I'm going to bring down an arrow down here and hit that. It's not going to come straight up, so I'm going to just kind of carry over. Okay, number 6. So number 6 I've got factored, so let's do x-intercepts. And they are 2, 0. I like when these are already factored. -3, 0, and 5, 0. My vertical asymptote is going to be x equals 1 and x equals 4. My horizontal asymptote, yucky, is going to be a slant. So let's see, I've got an x to the third on top and an x squared. So I'm going to have to multiply this out. Now let's multiply. So this gives me an x value. That gives me, whoops, how about a negative? That gives me -x cubed, positive 5x squared, and that gives me -4x. Change my signs. That gives me -x squared, and that gives me 15. And then I need to multiply by what? -1. And I'm not going to finish because this is all I'm worried about. Just need to find your equation, -x minus 1. Okay, let's find our y-intercept. So that over, let's see, -30 over 4, basically. So that would be -15 over 2. On at 1 and 4, I've got one, let's see, a point at 2, -3, and at 5, and 0, -15 halves. And your slant asymptote is -1 and a slope of -1. Anything here? And remember, you can cross slants or horizontals. It looks like this right here. I would follow this point and come down. At 1, I don't have a double, so I would say this is going to come up here. 4 is not a double either, so I would say this one comes and follows down as well. It says, answer the questions about the rational function f of x. Describe the following statements. For 1, it says a is less than 0, and 0 is between b and c. It says the function is discontinuous at x of a, x equals b, and x equals c. So basically we have vertical asymptotes or we have holes. We don't know what we have there, but it kind of gives us an idea. It says y equals x as the end behavior model for the function. So basically we know the numerator is bigger than the denominator, and we have a slant asymptote here. As x approaches a from the positive side, your function approaches infinity. And as x approaches a from the negative side, we have the function approaches negative infinity. So it looks like we have a vertical asymptote at x equals a. As x approaches b from the positive side, your function approaches 2. That's a little bit different. And as x approaches b from the negative side, your function approaches 2. So it looks like we have a hole here. So remember up here it said it gave us some information here. So at A, it was a vertical asymptote, and it looks like I have a hole here, and it's going to be at B2. At C, if you approach from the positive side, it approaches infinity. From the negative side, it approaches negative infinity. So I would say this is another vertical asymptote at x equals C. So it says list all vertical asymptotes. So we found x equals A and x equals C. All holes, we found a hole at B, comma 2. When your function, what's your function at C? This would be undefined because at C we have a vertical asymptote, so undefined. All right. It says, what is the degree of the denominator? So on the previous page we said that since we have a slant asymptote, we have y equals x, so your numerator has to be greater than the denominator. So the degree of the denominator is going to be, and we've got to look at this. So we've got vertical asymptote at A and C. So we know we've got those already in the denominator. And we have a hole. So right now we've got 3 things in the denominator. So I'm going to say 3 in the denominator. And if the numerator has to be greater than that, I'm going to say it's 4. Okay, it says sketch. So let's see what we can do to sketch. So here is my axes. Okay, since our vertical asymptotes are at A and C, it says A is less than 0, and C we know is between, it says 0 is less than B, which is less than C. So we do know something about those. So I'm going to say A is less than 0, so I'm going to put it over here. And we know that C is greater than B, which is greater than 0. So I'm going to put it somewhere over here. And this is C. We know B is a hole, which is at 2. And we know that it's smaller than C. So how about we say this is B, and it's a hole at 2. Remember, that is your hole. Okay. We have a slant asymptote at y equals x. And then I think that's all we have. Okay, so we need to figure out like where our lines go. So over here it said if we approach x from the positive side, A, it goes to positive infinity, and from the left side it goes to negative infinity. So A infinity, and from the negative side it goes to negative infinity. So this is going to go here. So I'm going to have a little picture down here, and this goes up here. All right, let's see what else it says. It says your other vertical asymptote C from the positive side goes to infinity, and negative side goes to negative infinity. Okay, so C from the positive side goes to infinity, positive side to infinity, and left side goes to negative infinity. So I'm going to have a little figure up here, and this one looks like it's going to connect. So I'm going to go up through here and go through the hole and connect through there. So it looks like we automatically, it said nothing about this, but it looks like we have an x-intercept, and I'm going to call that K. All right, so we kind of forced an x-intercept, which is going to help us. It says write an equation using your conditions. So remember we said denominator was 3. So let's call this f of x equals, okay, so I've got an x minus a. I've got a hole at x minus b, and I've got a hole at x minus c. Now, the reason why I went ahead and said minus for all of them is because no matter what number I plug in, if I were to plug in a positive, that would make that minus. If I were to plug in a minus, that would make that positive. So no matter what, I'm just going to go ahead and make them all minus. Okay, because I have a hole at x minus b, remember I have to put that on top as well. Okay, I said my numerator had to have an exponent of 4. But remember, we plugged this in right here. We caused an x-intercept of k. So I'm going to say x minus k. And I'm going to go ahead and put an exponent of 3, which causes this to be an exponent of 4. I went ahead and made that an exponent of 3 since I went through and looked like a cube to me.